this video I talk about strings. Strings in Rust are UTF-8 data, and there are different string types. In this video I explain the differences between them. In this example I'm using a string called S and a string slice called T. One is denoted by string, the other by &str. And these are the two most important string types. If you look at the string size, you get that a slice is 16 bytes, that is a pointer to the beginning and a length of the string. And S is 24 bytes, of course on a 64-bit machine, because the string actually owns the allocation and also keeps a record about how much is allocated. That is why if I type a string constant, I actually get string slice. Whereas if I do .toString, I allocate memory for it and assign it to the variable S. In this program, I show the values of the strings as well as the byte sizes. And then let's see what this does. So this first is the string value of the string variable, 24 bytes, as we have already seen in the IDE, and a string slice of 16 bytes. Here we see 8. What's that? That's the size of a mutable string reference. That's just a reference to a string and is a third string type, which we will talk about later. In this example, I show how to convert between the two string types. Here I define a string, and there already a conversion happens because this string slice constant is converted to a string by allocating memory on the heap and assigning this to the string variable. So that's your conversion from string slices to strings. Here is the other way around. That is the slice operator. Here I take a slice of the string and assign it to this variable, which is then automatically of type string slice. Let's see what happens. Remember that I took a slice from 1 to 2. So the string is ABC, and the string slice is just to be because 1 is the index of the first letter we take, and 2 is the index behind the last letter. Note that there's also this notation, which takes one more character, because this is when you want to give the first and the last index you want to take. That's actually an important difference between UTF-8 data and just byte data. Here is a byte string literal. This B, in quotes some letters, gives you just the bytes you type here. So if I, for example, put here this as a byte sequence, then I get X has the type a slice of bytes. Yeah? That's different from a string slice, because it's here by the type not known that these are valid UTF-8 data. Therefore, to actually get a string out of this, I have to call the function std from UTF-8, and that converts the byte slice into a string slice. Or actually, since this can go wrong if this is not valid UTF-8 data, what I get as a result is first some type called result with two template arguments, namely a string slice or a UTF-8 error. That's an algebraic data type, which is quite common in Rust functions. Either it's a correct string slice or it's an error. I know here that things will go well, therefore I can just call onWrap, and so the variable B has the proper type a string slice. So therefore this will exactly work as expected. I see PQR printed here. Of course, checking that the byte sequence is valid UTF-8 data is a process which takes time, so it costs you performance. So just to show that it can also be done differently, is you can use the function from UTF-8 unchecked, which does not check whether the byte sequence we are looking at is actually valid UTF-8 data. It's just blindly converting things into a string slice. So the result here is just a string slice. However, since this is obviously not safe, we have to put it into an unsafe block, like here. Notice that here is no semicolon at the end, so therefore the last expression in this curly brace set here is evaluated and is the result of this whole unsafe block, and that is what is stored in the variable b here. So here we skip checks, and obviously this is only then okay if you really know that the data is valid string data. I'm presenting this here to show you that Rust, yes, it has many checks and safety rules, but if you need to, you can just break the safety with an unsafe block. Let me run this. It runs fine. Obviously, we can't notice the performance difference here, but for larger byte sequences, this might matter. Finally, I want to talk about string arguments. Of course, you can use either strings or string slices as arguments with the obvious consequences. But there's some other nice thing. If you look at this program here, there's a function f which has a string slice as an argument, an immutable string slice. And here I just print it. But there's actually two different ways you can call this. If you have an actual string keeping the allocation, like here, s, you can use the ampersand s. That is a reference, an immutable reference to a string. And notice that this can automatically be converted to a string slice. That's for convenience. Likewise, if I take a slice here, an actual slice, and call the function directly with a slice, then I don't need the ampersand. That means if you want to write a function who takes an argument which is essentially just a slice of strings, then you should not make this type here a reference to string, but rather a string slice. Then the calling is much more flexible. Let me demonstrate this. Indeed, it works. In this video, I've shown you the differences between strings and string slices in Rust. I've shown how to convert between the two and how to use slices as arguments for functions. One important point which must stick is that string data in Rust is always properly encoded UTF-8 data. The type system actually protects you by this. That is it for this video. Thanks for watching.